This video will cover the topic of the distributive property and combining like terms. Be sure the date and topic are at the top of your page. The essential question for this video is how do we incorporate the distributive property and combining like terms? In our most recent work, we have practiced combining like terms. We've also reviewed and added to our knowledge of the distributive property, and this video will give us an opportunity to do both together. Let's start by looking at this example. So I have a whole bunch of stuff going on here. I have 3 outside the parentheses of 2x plus 5, and then I have a plus d and plus 3d plus 1. And I want to write this in the more simplified form. That means I want to combine like terms. However, I also have some distributing to do before I can do that. So I will take 2 steps. So the first step in my 2-step simplifying is to distribute anything that needs to be distributed. Makes sense? Step 2 is to combine like terms. So this seems really basic, but there's a lot that can get in our way while we're doing it. So just always remember to do these one piece at a time. I've rewritten our example, and I'm looking at it and I see that I have this invisible multiplication symbol right outside my parentheses. So I need to do some distributing, and I'm going to do that first. 3 times my 2x means I have 6 x's, plus 3 times my 5 means I have to add 15. The parentheses is over. I am done distributing. I do not need to multiply anything else times the 3. But I still have what's left from before that I need to write down. Right? So I really have 6x plus 15 plus 3d plus 1. From there, I look for any like terms, and I see that I have a 15 and a 1. Those are both constants that can be combined to make 16. So I can just go ahead, leave my x's and d's as they are. There's nothing else that I can combine there. So I have 6x plus 3d plus 16. And that's my final form for this expression. Right? That's the most simplified way to write it. So first I distributed, and then I looked for any terms that could be combined. For our second example, I have 7y plus 4 parentheses 2y plus 6, all in parentheses. So my first step, of course, is to distribute, and this is where my invisible multiplication is, right? 4 outside the parentheses. So I'm going to take care of that first, and this is kind of like our snow cone that we do with the order of operations, right? I'm going to take care of that, rewrite it, and then do what's next. So I have my 4 times my 2y, which makes 8y, and then my 4 times my 6, I'm going to add that, which is 24. So I've taken care of that. I'm going to rewrite what is left, and then I'm going to go on to step 2, where I'm going to combine what I can. And so I see here that I have 7 y's and 8 more y's, right? That's my little highlighter there, which means I have a combined total of 15 y's, and I'm going to end with my constant, which is 24. So all of that just became 15y plus 24. That was my most simplified form. Sometimes it gets a little more complicated, but we still need to do our 2 steps. So let's look at a bit of a longer one. I've got a lot going on here. Make sure you copy this down correctly. But I still, no matter what, need to do my distribution first. The difference here is that there are 2 sets of terms that need to be addressed. I'll do them one at a time. So let's get started here. I'm going to multiply my 2 times my 6w, which makes 12w. And then I'm going to multiply my 2 times my other 2. So I'm going to add on 4. I'm done with that portion, and I'm going to now look to the next section. I have to distribute this 3. So if I distribute my 3 times my 2w's, I end up with 6w's. And if I distribute my 3 times my 1x, I would get an additional 3 x's. And of course, these are being added together, so I'm going to go ahead and add that together. And then I'm going to, just like before, look for any like terms. I see that I have two variables or two terms that use the variable w. We'll go ahead and combine those first. So 12w plus 6 more w would be 18w's plus our 3x. That wasn't able to be combined with anything, and plus our constant of 4. Notice that I was sure to write the constant last. So we took this really long expression, right, that was up here. This was really long and daunting, and we wrote it just in this simplified form, which is a little less overwhelming to look at. Our next one might be a little tricky. If you look at it carefully, you might be able to see the difference. And it is that there is a subtracting symbol between the two sets of terms rather than addition. But just like before, we'll take this one step at a time, and we'll do the first part just like normal. So we have to distribute our 2. So 2 times 3 r's mean we have 6 r's to start. And then we have 2 times a positive 2. So we're going to add 4, right? That's our constant. And then the next part is a little tricky. I know that this is a subtracting symbol, but I'm actually going to look at it as a negative. So what I'm going to do is think of this more as a -3, right, as a unit here that I'm going to distribute. So if I have a -3 times my r, right, that has an invisible 1 there, so it's really a 1r. That means I have -3 times 1, which would be a -3r, so I'm going to record that. And then I have the -3 times this 5, so we would be adding a -15, because -3 times 5 would be a -15. And now I'm going to look for common terms, so let me highlight what I have in common. I have a set of r's that could certainly be combined, and I have a set of constants that can be combined as well. So I'm going to go ahead and take care of that. Let's start with my variables first. So I have 6r, and I have this kind of -3r, right? So if I combine that together, I have 3r's total, right? And then I have my 4, and I have a -15, right? So I'm going to be adding, this tells me it's adding a -9, because 4 and -15 is -9. However, you might also see that sometimes as 3r and just say -9, because if you are adding a negative, it does the same thing as subtracting that number. And I think these are the trickiest of the problems that we're going to be looking at when we're practicing this skill, but I promise that we will practice and practice and hopefully become more comfortable and confident with these types of questions. We might at times even see something like this, which looks really complicated, where we have to do everything from the last problem, but we also have to remember one more thing, which is that we have kind of that invisible 1 right there that's not, explicitly written. So we have to pay attention to all that. So once again, I'll kind of just walk you through this one. So we have the 2 times the 4x, which means we have 8 x's, and the 2 times the 3, which means we're adding 6, because 2 times 3 is 6. And then in the second section, we have a -1 times 3x, and -1 times 3 is -3, so we have -3x's. And then we have a -1 times 2, which makes a -2. And I look for any like terms that I see here, and I see my variables, and I see some constants that can be combined. And I would go ahead and put these together. So 8x with a negative or subtracting 3x means we have 5x's total, and 6 and that -2 would make 4. Right? So we have this whole long expression that seems really complicated, but really it's the same thing as just saying 5x plus 4. And it gets a lot easier when we practice. It won't come naturally right away for all of us. I promise you that we'll get better at it though. And it seems obscure to know this skill, but when we start using variables and expressions to represent real life situations with unknowns, it'll be helpful to take a really long, complicated expression and turn it into something a bit more simple to work with. In the meantime, here's one last practice problem that I want you to complete before you come to class. Use the distributive property and combine any like terms to write an equivalent expression that should hopefully be a lot shorter. And remember that the essential question for this long video was how do we incorporate the distributive property with combining like terms? And we will certainly practice this in class, but please come to class with any questions that you might have on this kind of tricky topic.